Hello, students. Hope you had a great break. Welcome to get back and get going with some gas laws still. We set the foundation before we left, and we're actually going to revisit that foundation now that you've had a week away. Hope it was restful. And now let's come back and regroup and remember what we did right before we went to break. We're going to start off with the Kelvin scale, and you have one of these papers which has been handed to you, says Kelvin scale right there. And these are going to be your notes over the Kelvin scale. And we have already dealt with the Kelvin scale. So if you're saying this sounds like something we've already done, you're right. If this does not feel like something you've already done, then that's something you want to be sure you pay very close attention to. Because I'm going to go through this pretty quickly since it should be review. If it's not review, be sure you take the time to master this before we move on. So on your notes page that looks like this, okay, you want to be sure that you fill in the blank, and we're going to talk about what the Kelvin scale is and how to use it in calculations. Because with gases, this doesn't apply to any other phase of matter, but with gases, we must use the Kelvin scale. It's the only one that properly works for gases, okay? So we call it the Kelvin scale because of Lord Kelvin. His full name is Baron William Thomson. There you go. Doesn't that sound cool? He did experiments with gases and realized that the Celsius temperatures weren't matching up. We can't say, oh, this is 20 degrees Celsius, this is 40 degrees Celsius, so I expect this to be twice as big a balloon. It didn't work that way. Okay, and we're dealing with gases. Again, this is applying to gases. This only really occurs with gases. The changes when we're doing with solids and liquids are itty bitty tiny numbers. Okay, so it doesn't matter with solids and liquids. It's only with gases. Also, we don't want a temperature scale that could give us a negative, because that could be very weird as we do more work with gases. So he came up with this idea of what he called a absolute zero temperature scale, and we then later on called it the Kelvin scale in his honor. Okay, and the idea is the absolute zero is where there is zero energy left at all. That would mean even the electrons no longer have energy to fly around the atom, meaning those electrons would even like come crashing down into the nuclei. So what's going to happen when a negative electron and positive proton in the nucleus touch? We get those weird phases of matter that we looked at before break. You don't need to know about all that theoretical physics stuff about what happens when you get to absolute zero. Just know absolute zero is the lowest temperature we can go. It is a zero mark. There are no negatives on the Kelvin scale. And that's a great thing that there are no negatives on the Kelvin scale, because if there were, we'd have problems. We would get negative pressures and negative volumes. And think about it for a minute, okay? Like pretend I'm holding a box. It's got a certain amount of volume in it. What would a negative volume look like for that box? Like clearly that would never exist. It can't exist, right? Like I could shrink the box smaller, 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 and then zero. And that's the volume. Like the volume zero is the lowest a volume could ever go. It's totally like just stupid to think about a negative volume being possible. All right. So that's another advantage of the Kelvin scale. It is proportional. If I have a balloon here at 100 Kelvin and I have a balloon here at 200 Kelvin, I expect the balloon at 200 Kelvin to actually be twice as big. So it's proportional. That's a great thing. And there will be no negative volumes. There'll be no negative pressures. That'll work out really great too. So for gases, we're always going to use kelvins. You need to be able to measure, because we're going to be in lab, you need to be able to measure with a thermometer Celsius and turn it into Kelvin. So how do we do that? Well, we did practice this before you left for break. To have the Kelvin, you're going to take the Celsius and you're going to add 273. Now, I know I told you 273.15, okay? Like, yes, I'm just giving a quick rounded number for our purposes here, okay? 273.15 is a much better number. It's actually, there's lots of decimals to it. Okay, but this is good enough for most of the work we need to do. 31 degrees in lab means I would add 273 to it, and that would be my kelvins. What if I have the kelvins, and then to report a final answer, I want Celsius? Well, then we just reverse the equation. So whereas to get kelvins, I add 273, to get Celsius, I would subtract 273. And we practice that a little. We're going to practice it in just a moment too, okay? But I want to remind you of this, and this is important enough. I put it right there on the notes for you, okay? So check down here, bottom of your notes down here. Important enough for me to put it there, okay? Kelvin temperatures cannot be negative. If you ever are holding a calculator, doing a calculation, and you see a negative on the screen for Kelvin, you did something wrong. Try again, okay? If you get a negative for Celsius, that's okay. Celsius can go negative. Kelvins never go negative, so just watch out for there. Okay, so that's actually all I had to say. This video was meant to be quick. Probably actually I talked longer than I expected. Oh well. You have some practice problems now with these equations to do down here. So, okay, they look like these here. I have some Celsius, I want you to convert them to kelvins, and I have some kelvins and I want you to convert them to Celsius. So again, kelvins cannot go negative, so none of these guys over here on the left should be negative. And Celsius can go negative, so it is possible some of these over here on the right are negative. Okay, that's all I have for you about Kelvin. This was, again, just a review video, not a let me teach it to you video. If this seems like the first time that you have ever heard of using the Kelvin scale, you want to proceed very carefully to be sure you've mastered how to convert from Celsius to Kelvin. That's what you need to do. Master converting from Celsius to Kelvin or Kelvin back to Celsius. If you master that, then you're good to go with Kelvin's law. Have good luck on your practice, and please, of course, turn it in when you're done.